Welcome to History of Marine Science. This is Chapter 2 from an Introduction to Oceanography. This chapter is going to be dealing with the brief history of oceanography and how science was applied to ocean seafaring and ages of exploration. In Chapter 2, we'll be taking a look at some of the following concepts. Understanding the ocean began with voyaging for trade and exploration. Seafaring expanded human horizons. We're going to take a look at the Chinese organized voyages of discovery and the age of European discovery, which was launched by Prince Henry. We're also going to take a look at how voyaging combined with science to advance ocean studies and contemporary oceanography making use of modern technology. All right, the overview of Chapter 2. Primary concept: the ocean didn't prevent the spread of humanity, but it actually helped in the spread of humanity. As a matter of fact, by the time the European explorers set out to discover the New World, most native people had already spread out across much of the world. We also need to understand that any culture that was able to build rafts or small boats or have skills of small boat navigation, they had the economic and the nutritional advantage over less skilled competitors. So it evolved as a way to maximize access to resources. Seafaring did. So periods of extensive maritime exploration and the marine projection of political power by nations, that all preceded scientific investigation. So it was all about exploration and political power. Then later, seafaring became about scientific investigation. A couple of investigations we're going to talk about. Captain James Cook, you probably heard about him. The British Royal Navy, they were probably the first ones to apply the principles of scientific investigation to the ocean. There was the HMS Challenger, which was the first extensive expedition that was dedicated totally to research. And then modern oceanography, which is developed and guided by a whole huge group of institutions and governments, not just individuals on single expeditions. In the past, there were individuals that struck out to learn stuff. Now it's sort of guided by institutions and governments. So early people traveled the ocean for economic reasons. It offered them the benefit of mobility and greater access to food supplies. If they had that raft building or small boat navigation skill, they had an economic and a nutritional advantage over competitors. The first direct evidence we have of voyaging, traveling on the ocean for a specific purpose, comes from the Mediterranean Sea. Now, the Egyptians organized shipborne commerce on the Nile. The first regular ocean traders out into the Mediterranean, the Cretans or the Phoenicians, who they kind of took over maritime supremacy in the Mediterranean. The Phoenicians did after the destruction of the Cretan civilization around 1200 before current era, BCE, pretty much the same as BC. The Phoenicians traveled right to the Straits of Gibraltar, which took them out into the Atlantic Ocean, and they made it as far as, let's say, the British Isles and down the west coast of Africa. The Greeks, they began to explore outside the Mediterranean and into the Atlantic Ocean about 900 to 700 years before the current era, BC. And once the Greeks got going, we started seeing the development of cartographers. We saw the founding of the Library of Alexandria, and Eratosthenes, who was a librarian, he developed some very significant concepts and understandings, including longitude and latitude, and the fact that the world was a globe, and he began to understand the size of the world. So cartographers are chart makers or map makers. That's what a cartographer is. Cartography is map making. And those cartographers recorded information about locations and landmarks and ocean currents. The Library of Alexandria was founded in the 3rd century before the current era, BC. And this library stored information on every aspect of human endeavor. It was massive, and its destruction really stopped the development of humans for almost 1,000 years. And then the second librarian at Alexandria, this guy, he was able to calculate the circumference of the earth. He invented this system of longitude and latitude, so there's a massive use of the ocean to really begin to understand the globe, the world, in this 1,000 years or so before BC, before the current era. And of course, the principles of celestial navigation were invented right there at the Library at Alexandria. So this is how he determined the circumference of the globe, just basic trigonometry. So he recognized that the sun was very far away, And so that meant that the sun's rays came in to the earth nearly parallel. And he also knew, basically noticed, observed, which is what scientific, the scientific process is, making observations. He observed that on the longest day of the year, the solstice, that the sun's rays went straight down into this vertical well in the city he lived in. And he also knew that about, in their terms, 785 kilometers away, they knew that distance, was another city in which a pole sticking straight up cast about a 7-degree shadow. And so if you use basic trigonometry, if you draw a straight line down the well to the center of the earth, and another straight line parallel to that 7-degree angle and that shadow being cast in that pole, if you use the concept of opposite angles that cross over two parallel lines, opposite angles are equal, then you know that there's a 7-degree angle between the well and that pole. And that 7-degree angle is about 1/50th of a circle. So you know the distance from the well to the pole is 1/50th of a circle, or 1/50th of the circumference of the earth. And back in 230 BCE, he was able to determine the circumference of the earth within about 8% of its true value. This is just an amazing example of the knowledge that was kept at the Library of Alexandria. And again, most of it having been developed through maritime exploration. In 220 BC, this was the world according to the Library of Alexandria. And you can see there are actual lines crossing the map, north to south and east to west. Those are the beginnings of the lines of latitude, the lines that go from east to west, and the lines of longitude, the lines that go from north to south. And in this chart, and you can actually even see just how well they understood the general shapes of the continents. You can see Italy and Spain, you can see what the British Isles are, Africa is known as Libya, and then Arabia, and then India, all pretty good understanding of the actual shapes and even the distances. But these lines of longitude and latitude were put through cities and important locations, and they weren't evenly spaced out as the lines of latitude and longitude are now. And they put Alexandria at the mouth of the Nile right there in the center. So let's talk a little bit about latitude and longitude. Lines of latitude and longitude are the imaginary lines that we draw on the globe to allow us to pinpoint a location on the globe. Lines of latitude are parallel to the equator, and they run from east to west, but they are stacked from north to south, and you can see that on the far left. The 0 line of latitude is the equator. 30 degrees north latitude is a 30-degree angle running from the equator to the center of the earth, and from a point near Jacksonville, Florida, to the center of the earth. And then 60 degrees is further north, and of course the North Pole is at 90 degrees. Those are lines of latitude. They are parallel to one another, and they run from north to south. The lines themselves go around the world, east to west, west to east, and they are stacked from north to south. Longitude is a little bit of a different beast. When you're trying to decide what's going to be the 0 line of latitude, it's pretty easy to do. You use the center of the earth right there in the middle. That'll be the 0 line. So that's the equator. But how do you come up with the 0 or the prime meridian? Lines of longitude are sometimes called meridians. How do you come up with that prime meridian, that 0 line? Where do you put it? So back in the time when these decisions were being made, England was the powerhouse in the world, and so the decision was made to make that prime meridian run through England. And the city of choice was the city of Greenwich. So that's where the concept of Greenwich Mean Time comes from. Greenwich Mean Time, or the prime meridian. That is where the 0-degree longitude line is. And the lines of longitude go around the world from north to south, and they're stacked from east to west. And as you go west from Greenwich, you're in the western hemisphere. As you go east from Greenwich, you're in the eastern hemisphere. That's how the United States is a western culture. Anything west of Greenwich is in the western hemisphere, and it goes around 180 degrees. 10 degrees west longitude, 20, 30, 40, 60 degrees west longitude, all the way around to the backside of the globe in the Pacific Ocean, where it's the 180 degree west longitude. And then it starts from 0 at Greenwich Mean and goes east as well, 10, 20, 30, 40, 50 degrees east longitude. The thing about the longitude lines is they converge at the poles, so they are not parallel to one another. The Polynesian Triangle is this concept of how the original peoples moved across the Pacific Ocean. And the ancestors of the actual Polynesians, who we think inhabited the Hawaiian Islands, theoretically spread from Southeast Asia or Indonesia to the east, to New Guinea, and then the Philippines, and they had done that by about 20,000 years ago. But the mid-Pacific Islands, a little further out, they had been colonized about 2,500 years ago. And that would happen through this huge movement of what we refer to as a Polynesian Triangle. And if you look at this Polynesian Triangle, it's bisected by the equator. And north and south of the equator, the trade winds blow from the east, northeast trade winds, southeast trade winds, which means the prevailing winds across this section of the massive Pacific Ocean are from east to west. And so the theory of the Polynesian colonization is that the original inhabitants of Southeast Asia and the New Guinea area, they would sail into the wind until they ran into an island. But if they got to a point where they did run into an island and they were running out of food and water, then they would just simply turn around and let the prevailing trade winds blow them back to their original location. But this is the theory as to how the original indigenous people spread from Southeast Asia and spread to the east across the Pacific Ocean. And this also includes those that went all the way over to Easter Island and, of course, the Hawaiian Islands. Here's an example of a Viking ship from about 900 AD. And basically, this is a reconstruction. The painting is a reconstruction from a ship that was found at the bottom of a Norwegian fort back in 1880. And it's just a very standard setup for an ocean-going vehicle. But the Norwegians, or I should say the Vikings, had tremendous success in their era in conquest, and because they had an understanding and ideas about seafaring and shipbuilding. The Chinese were the first to invent an actual compass, which is what you can see in the lower left, and that was used to point them to true north. And they used that to have some idea where they're going and which direction they are going. They also, the Chinese, were able to develop the central rudder and watertight compartments and sails. And not only sails, but multiple masted ships. And their mastery of seafaring techniques and shipbuilding allowed the Chinese to be massively wealthy and really spread their civilization across much of Asia and the Western Pacific. So the Chinese undertook some serious organized voyages of discovery. And in the 1400s, early 1400s, they moved into the Indian Ocean through Indonesia and then off to the tip of Africa. And again, they were able to do this because of these advances that they had developed in shipbuilding of central rudders and watertight compartments and multiple masts. So you can read the details in the book of their movement across the Indian Ocean over toward northern Africa. But again, it was a significant event, and it really allowed them to garner tremendous amounts of wealth. And there is the map of the origin of all 7 voyages being there in the middle of the Ming Empire. And they came around through Thailand and through Indonesia, between Malaysia and Sumatra, over to the southern tip of India, and then on up into Arabia, and then eventually around that northern tip of Africa as far south as almost into Tanzania. And all these stops, they were able to trade and learn and take on tremendous amounts of wealth. And it's a big part of the spread of this Chinese civilization. Europe also had an age of discovery, and that was during the Renaissance period. Most well-known was Henry the Navigator, and he was able to compile detailed charts as he explored the west coast of Africa. He did some very impressive explorations. And then, of course, Christopher Columbus, who actually never saw the mainland of North America, but his adventures inspired all those other people that did sail to the New World. And you've probably heard of Ferdinand Magellan. And even though he died attempting to circumnavigate the world. His crew, well, a very, very small part of his crew, actually was successful in circumnavigating the globe. About 260 sailors set sail on that attempt out of Portugal in the early 1500s, but only 18 of those sailors actually arrived back a few years later. All right, James Cook, well known. One of the things that James Cook was really well known for was making friends with the Polynesian people all across the Pacific. But in the end, it was something he did that offended them on the big island of Hawaii that he met his doom, as he just basically had his head lopped off one day because he had broken one of their taboos. So James Cook was a commander in the British Royal Navy, and he's credited with leading voyages that really tremendously contributed to scientific oceanography. So beyond the spread of political power and the acquiring of wealth, Cook's voyages were mostly about scientific discovery. Some of the things that he discovered, he was able to, while out at sea and observing the planets and the stars, he verified calculations of planetary orbits. He was able to chart New Zealand and the Great Barrier Reef and Tonga and the Easter Islands. He was able to, as I said, initiate these friendly relations with many of the native populations. He did an amazing amount of sampling of marine life and land plants and land animals. And he also did a lot of recording of data with regards to the ocean floor and geologic formations. Then we moved into a period in which it wasn't individuals undergoing exploration, but it was governments undergoing exploration. The United States Exploring Expedition was launched in 1838, and it was a naval/scientific expedition. The HMS Beagle, where Charles Darwin served as a naturalist, went to South America and also into the Pacific Islands. And this is a chart of the HMS Challenger, which between 1872 and 1876 was the first oceanic expedition that was dedicated solely to scientific research. And it had an amazing trip. All right, in the 20th century, as you might expect, we had tremendous advancements in ocean exploration. There were polar expeditions, charting and mapping both the North and the South Pole. The Meteor, which was a ship with the first expedition to use modern optics and electronic equipment for oceanographic investigation, including the mapping of the seafloor. The Atlantis was a research vessel that confirmed the presence of the Mid-Atlantic Ridge. And we're going to talk in detail about the Mid-Atlantic Ridge and why knowing it's there has been such a monumental advance in our understanding of the Earth's geology. And then we had these bathyspheres and bathyscapes, which were submersibles that descended into the Challenger, in the Challenger Deep, which is another one that went down into the Mariana Trench, which is the deepest trench in the ocean. It's over in the Pacific Ocean. It's where two plates converge and create a deep ocean trench. And the Challenger was also able to obtain samples by drilling. It was a drilling ship. And the samples that that drilling ship pulled up also able to provide some confirming evidence for this concept of seafloor spreading. The mid-ocean or the mid-Atlantic Ridge is where the seafloor is spreading, and the Challenger was able to drill and get the evidence of seafloor spreading. So massive advancements in ocean exploration occurred in the 20th century. And again, here's just a quick recap of the things we just talked about. With the Meteor expedition, the Challenger, the Glomar Challenger that drilled the ocean floor. And that was in 1968. So it was 1968, which probably seems like a long time ago to you, but I was 7 years old. And that is when we really first began to use ocean expedition and information to get an idea of what was actually happening on the seafloor. So briefly, we'll talk a little bit about some of the technology used in the 20th century to make these advancements. The first being the echo sounder, the ability to map the ocean floor using sound waves, and the fact that the sound waves, if emanated from the ship pointing straight down, they're going to bounce off the seafloor and travel back up to the ship. And if the ship has a listening device, It can determine the time that it takes the echo to travel from the ship to the seafloor and back up, and you can get the depth of the ocean using that technology, beaming sound waves to the bottom and measuring the time required for the sound wave to bounce back to the ship. So if that round trip time is known, the distance to the bottom can be calculated, and this technique was first used on a large scale by the German research vessel Meteor back in the 1920s. Some institutions that have come to be that basically oversee the large-scale complex research projects, and some of these that you've likely heard of, like Woods Hole Oceanographic Institute, the Scripps Institution of Oceanography, and then Lamont Doherty Earth Observatory of Columbia University, all major institutions that have hundreds of millions, if not billions, in research dollars in play almost at any given time to try and allow us to know more about the ocean world. There's also NASA, National Aeronautic and Space Administration. There is also NOAA, the National Oceanic and Atmospheric Administration, and NASA was instrumental in launching, of course, those first oceanographic satellites that gave us an understanding of wave heights, sea surface temperatures, sea surface heights themselves, sea level changes. Satellite altimetry can give us very, very exact data on wave heights and the sea level heights and sea surface temperatures, and all these things help us understand, again, maybe the impact of warming on the Earth, or what's going on with El Nino, and then, of course, also what's happening with ocean waves. And then NOAA was instrumental in creating some of the robotic devices that have been used in undersea exploration. Here are the satellite projects, TOPEX, JASON, Aqua. Aqua and Terra are two satellites that fly in a polar orbit. And you can basically, if you Google Aqua satellite, you can get a daily group of pictures taken by those polar orbiting satellites. And what's different about polar orbiting satellites from the geosynchronous orbiting satellites that they use for weather and the GPS satellites for global positioning is those polar orbiting satellites orbit at a much, much lower altitude. And so the pictures are very high definition, very, very interesting, something you may actually want to take a look at sometime. And this is the NASA A-Train, the string of satellites that orbit the Earth, one behind the other on the same track. They are spaced just a few minutes apart, so their collective observations may be used to build three-dimensional images of the Earth's atmosphere, its ocean surface, and land topography. This is that graphical information, that GIS, which is a whole new industry and a massive industry opening up for those interested in this type of physical science. So that pretty much wraps up Chapter 2. Chapter 3 is huge. It's gigantic, right? It's all about the Earth and its structure, and specifically plate tectonics and the role that plate tectonics played in creating the ocean basins that we know today. So we'll see you on Oceanography Lecture 3, or Chapter 3 lecture coming up.